All right, so this video, let's talk about this Trimble GPS. So we see this excavator over there. We got a 323F, which is kind of the biggest excavator you can get without having to get a bigger lowboy. You're able to deploy it quickly. You had a smaller 316, but then you said you're using the Trimble GPS. And walk us through, what is that? How does it work? How much more money is it? What's the value add? And help people that don't know this world necessarily understand what the Trimble GPS is.
So the Caterpillar 323 over there, your current price right now with a wired up unit that can run with the GPS is probably around, I want to say maybe $300,000. And then the Trimble GPS, if you want a rover and the antennas that go with it, a base station, you're looking at adding about $45,000 to $55,000 of cost, right? So we're increasing the cost on the unit, but the way we look at it is it's kind of like analog to digital, tape to CD, or say tape to MP3, right? We're going from analog to digital. Before, the guys used to have to look at a paper plan to understand what's going on, but now with that GPS equipment, when they're digging a home, they understand where they're at in the world, X, Y, and Z. X, Y is where they're at lat and long, and then the Z is the depth. So we have somebody program the job in the office, and then when they're in the backhoe running the machine, he can see where his backhoe is in the machine and where he is in relation to that survey or that job, so he can dig right on the lines that he needs to at the depths that he needs to.
Okay, so walk me through this. You're saying that this whole job, this entire thing, somebody at the office sat down on a computer program and freaking put in all the elevations and all the plans. What does that process look like? Like, how does that work?
So we take a survey and essentially simplify it and give essentially 3D line work to it, right? So everything, we take that survey, we put it into the computer, and all that line work gets used on that. We drag that over onto the CAD program, Trimble Business Center, and then we digitize it the way we want, and we give that operator the X, Y, and then the elevation of the job that he needs to dig it to, so we can get the elevation for the concrete contractor to set their footings on.
Okay, absolutely. Now, do those plans go to the concrete contractor? Do they get it too, or how does that work? Is this something that passes from, you know, the builder to you guys to the next contractors, or is it?
So currently the builder puts it up on some sort of sharing resource on their website. We grab it, and then the concrete contractors grab it, a survey and the house plan itself.
And so they are interchangeable. You guys are sharing together. Is that on Builder Trend or?
We're not. The builder's sharing us the plan, the survey and the plan, sometimes in just a PDF format, and then sometimes in like a DWG format, which is a CAD type format. Okay. But after that, we're kind of separate, right? The concrete contractor's grabbing it and doing what they need to do for their guys to do their work, and then we're grabbing it and doing what we need to do. At some point, we can potentially create a drawing that both us and the concrete contractor can use to maximize the efficiency, but we have not done that yet. Okay,
so you're saying every job you guys have done, you're sitting on these 3D plans. What kind of resources have to happen for you to, and maybe we'll go like this, there's something more interesting to watch all the time.
Yeah.
What kind of resources as a contractor do you have to have in order to start doing those 3D plans? Like, you have a full-time person doing it? Do you guys do it, or who is it that's actually doing that?
No, so that software is very process driven. If I had to take a stab at it, I don't have it written down, but to create a job like this, they probably spend about an hour to an hour and a half. If you just wanted to create a 3D dig plan for this job site, you would probably have 45 minutes into it.
And who's the they? Who's actually doing that? Is that a staff person for you, or do you?
Yeah, in the office, that's Jake Trexel. Jake used to work in a dump truck for us, one of, I don't know, the best dump truck drivers we've had, right up there with Paul. Yeah. And we moved him into the office. He knows how it goes out here on the job sites, and he is good at designing the stuff back in the office because he's been out in the field.
That's cool. So he's been out in the field. What do you think does the software provider, does Trimble provide a learning system for people to get in, do the training, and understand how to do that? Do you have to go to DCT, technical college to do it, or how does somebody actually do that?
Yeah, just like anything. I mean, anybody can do it. It's just CAD software, right? And just like anything, a small business operator, you're just screwing around, tweaking around, figuring it out. And in this case, Jake was a dump truck driver, an equipment operator, and he came into the office and he's able to do it. So just with a little bit of tweaking and training and working on it, you can do it. Anybody can do it.
That's really cool. Okay, so this whole job is in there. Now, do the skid steer, the compact track loaders or the skid steer over here, does that have the information, or have you know, which machines all have that?
Yeah. So currently we haven't spilled that technology down to the skid loader level. With that being said, I mean, I think it's something that we'll eventually do as that technology grows and becomes maybe more cost effective. It would be worth spilling into the smaller equipment, but at this point we have not done that. In the near future, next 1 to 3 years, we would like to outfit every skid loader that we do grade work with that Trimble equipment, so they can understand where all the elevations are at on the job.
That's cool. So, okay, so the Trimble is not only where you are, as these guys are moving around and everything, but it's really about the elevation. So what you're saying is these guys come in, and as we're trying to figure out, is that what's feeding the grade? Is the GPS the grading thing? Or you see guys go out and hold the stick in the ground. Is that the same thing, or what?
So the stick in the ground that they're using is generally a rover, whether you see a surveyor or a contractor using it on a job site. It's a pole that has an offset, let's just say 6 feet. It's a little bit taller than that, but they put an antenna on top of that pole so it's above your head and any obstructions, right? You try to be mainly out in the open, but it can work close to trees. But you put that antenna on top of that pole with a 6-foot offset, and so when you're touching the ground, it's essentially taking the height of that antenna minus 6 feet where you're touching the ground and telling you the X, Y, and Z elevation of that.
Now, some of the equipment doesn't require a guy to stand there with a stick in the pit. What technology is that? And so you spent 40 grand additional on a $300,000 machine here so that you can have the Trimble GPS. Is there additional technology that doesn't have that maybe you could invest into, or what's the cutting edge stuff out there right now?
You know, there probably are more cutting edge applications, but with that being said, that's a huge leap. Like I said, from tape to CD or MP3, that's like going from analog to digital. Just so that operator has a plan in there and he knows right where his bucket is in relation to the plan and what the surveyor and the builder designed is just a huge step. There are some newer technologies with Trimble, like I say, with the skid loaders. They're starting to spill their technology down to smaller equipment, but with equipment in general, the bigger the piece of equipment is, the more stable it is. And so when you're putting GPS on that, that piece of equipment rocks, shakes, moves less than that one. And so you can get the accuracies out of it that you need. When you take an antenna down to that level and you're asking it to do 60 corrections a second, it can be kind of problematic. And so what some of the manufacturers started out by doing is they put a skid plate on a bar and then they have wheels out in front, right? So that doubles the stabilization of that blade that the skid loader is running. For us, we always want to be very tight and nimble, right, to get into jobs. And so we haven't done anything with those bars and the blades on them, but when they're able to get the technology mastered on a skid loader to run it from a bucket, that's probably when we become a purchaser. But right now, it's just something that's kind of in continuous development, because when you go from a big machine down to that small machine, all that shaking, rocking, bobbing back and forth, there's a lot of corrections going on there, and so somebody would have to slow down a lot more to make that system work
and the
really
stuff
well.
could break, I'd imagine. So it could break. It's on there. It's probably more expensive since it's moving more often.
No, it's not. No, and not to be contrary, but with that being said, I mean, all the Trimble equipment is ruggedized. They understand that all this stuff is moving, shaking, vibrating, pounding, and so to be honest with you, we have not had any issues with the Trimble equipment breaking down due to rough use.